All right, let's do some Mathity-Math. I have here my pencil and my eraser, because remember, sometimes we make mistakes, and that's okay as long as we learn from them and try to fix them. Okay, so this is a practice assessment for MYP1 math. These are the 6th graders. This is going to focus on patterns, so Criterion B, and we're really going to be working here with fractions, okay? So this first one here says, solve the problem step by step. Make sure to state what you're doing each step of the way. And so what I'm gonna do here is really work on kind of showing my work step by step by step, and then kind of talking about why I did what I did and see if we can see those patterns. Okay, so first things first, I'm just gonna write this problem right here. I have 2/5 plus 3/5, and I know that is going to equal 5/5, right? And then right here, I'm gonna write about what I did. And the idea what I did here was the denominators are the same, or you can say are equal. So the denominators are the same. There's a good math word, or you can say are equal. That's a good math word too. So add the numerators. There's another good math word. Okay, and so the denominators are the ones down here, and the numerators are the ones on top, okay? And that's what we did here. So then we're gonna have 5/5. So then we have 5/5. Okay, and that's gonna be equal to 1 because 5 divided by 5 is 1. And we know 5 divided by 5 is 1, so in this case, we could just write, all I did was simplify. Okay, so those are the 2 steps of this kind of pattern. The denominators are the same, so add the numerators. 5/5 is 1. That was just what we called to simplify, all right? And now let's go to the next one and see if we can kind of see this pattern, right? So again, I'm just gonna write what's going on here. So I have 6/7 minus 1/7, and that's gonna equal 5/7. And how did I do that? Well, again, it's that same pattern, right? The denominators are the same. So, add the numerators, right? Okay, that's it. That's the whole idea. The denominator is the same, so add the numerators. And now, I have 5/7, right? And that cannot be simplified any further, okay? And they have no common factors. So if you want, you could write that. You say no common factors cannot simplify. And again, look at these math words. Denominator, numerators, common factors, simplify. This is the math language we want to get used to using here. Okay, and let me go ahead and get in the habit here of boxing up these answers so we can see it. Okay, good job, good job. Okay, coming down here, it says create your own problem and then solve it to verify that your method works. And for this one, we don't have to explain it. We're just gonna kind of use this pattern to guide us. So what I'm gonna do here is I'm gonna do 2 examples here. Oh, actually, you know what? I'll do 3 examples. You could do something like this. You could say 7/10 plus 1/10 is 8/10. You could do that. That's kind of showing that the pattern still works. And then, if you wanted to, you could show that 8/10 does indeed simplify. And that'd be 4/5, okay? And if you wanted, you could use this piece as an opportunity to also show your knowledge of the power of dividing by 1 to simplify, okay? So there's one example. Okay, I could also do a subtraction example. And if I so I could do an example like this. If I really wanted to, show my stuff, I could make a little bit more of a complex example to show that the pattern still holds. And the pattern we're talking about is that how fractions work when they have the same denominator. So how about I do like this? I could say 4 11ths minus 1 11th plus 2 11ths plus 3 11ths minus 4 11ths equals, and we could again just kind of show the pattern works. All of the denominators are the same. There you go, so it's going to be 11. So 4 minus 1 is 3, plus 2 is 5, plus 3 is 8, minus 4 is 4. We actually are right back where we started, and that's okay. To check my math real quick, 4 minus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and 8 minus 4 is 4. And there you go. So you are just showing me that the pattern you established up here still works. Okay, let's go to the next page. Okay, same idea here, right? I just want you to talk about the patterns or the rules that work within these fractions. There we go. Okay, so here we go. I'm going to rewrite nicely. 3 over 4 times 2 over 5 is equal to, and I know when I multiply fractions, you do the numerator times the numerator, denominator times the denominator. So I'm going to get 6 over 20, okay? And this one you can just write, because you're multiplying, you just can write multiply numerators, multiply denominators, and you can actually kind of see this pattern kind of builds. It looks just like a fraction, right? Multiply the top and then multiply the bottom. Okay, so now we have 6 20ths, and we're going to simplify that by dividing by a common factor they share. And I know that they both share a 2 because they're both even, right? So I'm dividing by this, and 2 over 2 is 1. And remember, you divide by 1, nothing actually changes. So we're just, keeping it the same, but different. It's called the unity of opposites, right? Different ideas somehow make it work, right? So this is going to be the same, but it's going to be different. And that's going to give us 6 divided by 2 is 3, and 20 divided by 2 is 10. And so this kind of pattern follows the same pattern because, multiplication and division are essentially the same idea, just done front ways and backwards. But what you can do here for this idea is you can say, find a common factor, right? Check, that's the first piece. And then, so after we find that common factor, divide the numerator by the common factor. And then you can just say, do the same thing to the denominator. Oh my gosh, I've been over here the whole time, sorry. You could also say like, let's just write it out. Divide the denominator by the common factor. And those are the math words we want to get in the habit of using that helps us understand the concept, right? Numerators. Actually, multiply is a good one too. Common factor. Divide the numerator by the common factor. Divide the denominator by the common factor, right? So again, even in the language, you start hearing this pattern. Multiply numerators, multiply denominators, find a common factor, divide the numerator by the common factor, divide the denominator by the common factor, right? So there is also like a language pattern, okay? Okay, coming here, for the first step of this one, you don't actually have to describe this for the pattern. This is just something we want to know, that this 5 can be rewritten as a fraction. We just put it over 1, so it looks like this. 5 over 1. That's all, right? So 5 over 1 is the same as 5 times 2/3. And again, I want you guys to see it's the same pattern. What you're going to do here is you're going to multiply numerators, doot, doot, multiply denominators, doot, doot, right? So let's do it. Following our pattern, oopsie, right? If I multiply numerators, I get 5 times 2 is 10. And if I multiply denominators, I get 1 times 3 is 3. And the way I did that is I multiply my numerators. See, I'm just copying down actually what I did there. Then I'm going to also multiply, denominators. Okay, multiply numerators, multiply denominators, and that's where I'm at. Ta-da! And then for this one, at this point, again, for this, okay, we're just moving into mixed numbers. I'm not really assessing this. That's not the focus of this assessment. And we can just kind of look at this mathematically. You know, 3 will go into 10 3 times, 3, 6, 9, and there'll be 1 left over. So you have 3 and 1/3. And we can just call that part, because that is just division, essentially, division with remainders. For this one, we'll just write simplify, okay? That's okay. So now, the idea here is they want us to use this pattern to create our own example. So let's do it. I'll just pick some numbers. I'll say 1/2 times 2/3. This is one example, okay? Okay, and if I follow my pattern, I'm going to multiply the numerators. Ta-da! I'm going to multiply the denominators. Ta-da! Okay, and that's the first piece. And then the second part of my pattern said find a common factor. And so in this case, they're both even, so I know it's 2 again. Right? Following that pattern. And 2 divided by 2 is 1. And 6 divided by 2 is 3. And there is a simplified version. Very, very good. Now, if I really want to try and extend that pattern, you can do this. You can make a more complex example. We could do something interesting. We could say 1 over 2 times 2 over 3 times 3 over 4 times 4 over 5. And just see what happens, because the pattern should hold. Multiply the numerators and multiply the denominators. So 1 times 2 is 2, 2 times 3 is 6, and 6 times 4 is 24. Okay? 2 times 3 is 6, 6 times 4 is 24, and 24 times 5, I believe that's 120, but I'm not positive. Let me go ahead and get this. Let's see here. Let's see. 24 times 5, it is 120. Woohoo! Actually, you know, while we're here, I'll just go ahead and show you what I did in case I was going a little too fast. Let's see here. I said 1 times 2 times 3 times 4, 24, that's my numerator. 2 times 3 times 4 times 5, there's my denominator. Okay, so looking at this, I can again follow that pattern of finding a common factor. Now this one, you could use 2. There's also other common factors, but let's kind of talk about, let's just say we only used 2. So we followed that pattern, we found a common factor, and we divided the numerator by the common factor, and we divided the denominator by that common factor. We get here. And then hopefully you see, so I'll come back over here. So when we got here, hopefully you can see that, oh, they still have a common factor. So again, I'm gonna find that common factor, divide the numerator, and divide the denominator. Oh my goodness, they still have a common factor. So we're gonna keep repeating this pattern until they don't. And oh my goodness, they still have a common factor. Okay, 3 divided by 3 is 1, and 15 divided by 3 is 5. And there you go. Now, as you go through this, there's something hopefully you'll see, and that's the beauty of identifying patterns, is that if you look, here I divided by 2, here I divided by 2, here I divided by 2, and here I divided by 3. Well, 2 times 2 times 2 is 8, and 8 times 3 is 24. So coming way back here, I could have avoided all of this and just did 24 over 24, and it would have also got me to 1/5. But either way is fine, because I do want you guys to explore and test these patterns and show me what happens. And that is that page. Let's keep it going. Okay, so here we have a division problem, and this doesn't actually follow the same rules as multiplying, because when we divided by when the numerator and the denominator were the same, that was like dividing by 1, but this is different because this is a fraction. And so if I can't divide 3 by 2 and then 5 by 3 and expect it to be in proportion. So what we're gonna do here is, this is what we talked about when we learned about that pattern, understanding that dividing by a number is the same as multiplying by that number's reciprocal. So the idea here is, if I have 3/5, understanding that instead of dividing by 2/3, I can multiply by the reciprocal, right? You can understand you can multiply by the reciprocal, and that's going to give you 9 over 10, numerators and denominators. So now what this is a combination of patterns. Now some of you guys, that idea of multiply by the reciprocal, right? Multiply by the reciprocal, that pattern you guys sometimes call it is, you guys call it keep, change, flip. That's a good way to remember, but a real mathematical way to remember, we can call that multiply by the, reciprocal. That's a really good way of remembering that. Okay, so this is fine, but this is really, 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 really great. Okay, and then you are done with that one. Okay, and you've already talked to me earlier about the pattern of simplification. So if you want to write, if you chose to write no common factors, cannot simplify, that would be really great. I'll put a square here. That's an opportunity for you to expand. Okay, that's an opportunity for you to do that. Okay, coming down here, showing the same idea. So we know that 4 can be rewritten like 4 over 1. And instead of dividing, we're going to multiply by the reciprocal, which gives you 8 over 1. And again, this same idea, you can rewrite, this same idea up here, you can rewrite all of this down here. And I want you to do that. I won't do it now because you guys get the gist by now. But you would write essentially keep, change, flip, or if you really want to show your math language, multiply by the reciprocal, and then you get 8 over 1, which is the same as 8. And if you want to write that, you could just write simplify. Okay? And then here, it's just your chance to give me an example. I'll do a fast one. We'll just say, I don't know, 7 over 8 divided by 1/2. Okay, that's my problem. And what I'll write is, when I show my work, I'm just gonna say, that's the same as saying 7 over 8 times 2 over 1, right? So I'm displaying my pattern mathematically. And then this ties into the other pattern of when we multiply fractions, numerator times numerator, denominator times denominator. So these patterns do build. So I get 14 over 8. And now we jump into the next pattern that we talked about, the pattern of simplification, which is find a common factor, divide the numerator by that common factor, and divide the denominator by that common factor. Which then ties into our next pattern of simplification, which is when we just kind of divide. So 4 goes into 7 one time, and there'd be 3/4 left, right? So as we go through this assessment, as the problems get bigger and harder, the patterns you'll be using will be building and building and building. And that's something we need to see and use and explore. All right, keep it going. Woo! Okay, now we're getting into it. Okay, so here we have a subtraction problem, but you can actually see that they don't have the same denominator. They don't have the same denominator, okay? Our goal will be to find a common denominator. And the way we can do that, again, now this is a bigger pattern, this is a bigger thought. We want to kind of figure out how to find the common denominator, okay? And you can do this lots of different ways. One way we talked about doing it is by finding the prime factors. And so, for instance, when you look at the prime factors, when we go, you have a 3, and then that is prime, that's 1. And then over here you have 8, which can go down to a 2 and a 4. And there is a prime factor, which goes down to 2 and 2. And so what we do is we go between the two terms and we list out every prime factor, and you can cancel out prime factors. We won't do it in this one, but you'll see what I'm saying. So first things first, we have a 3. So we use that one's done. We go here, we have a 2, and we have a 2, and we have a 2. And so in this case, it is just multiplying denominators, but that pattern of finding prime factors still holds, and this gives you 24, right? So if we were talking about like the pattern that you would want to write down here, you could write something like this. Use prime factors to find a common denominator, okay? Math words, prime factors, common denominator. And we know it's gonna be 24. Now I kind of did a messy job here, so maybe I'll scooch over here real quick and show some more work. And stay with me here. So I have 2/3, and I'm gonna use my common denominator of 24. And what I'm gonna say here is I have 2/3, I'm gonna multiply that by whatever value it takes to get to 24. So how does a 3 become 24? Well, that's times 8. And like I say, in this case, it's the other denominator. And what I'm actually gonna do is I'm gonna multiply by 1. 8 divided by 8 is 1. So I'm multiplying by 1. And remember, when you multiply 1 by 1, nothing changes, okay? And then I come over here, I have 3/8, okay? And again, how does an 8 become 24? You multiply by 3. And again, that's multiplying by 1. And so the idea here is, and this is the pattern you could write, and this is gonna look kind of interesting, but you could be like multiply by, and I'm gonna put it in quotes, 1, because it's like a special one. This one is 8/8, but this one is 3/3. They're both still 1. So multiply by 1 to get common denominators. Now what I want you guys to see here is if I do this math real fast, we're using all the previous patterns. Now right here I am multiplying fractions. Numerator times numerator, denominator times denominator. And on your test, I'll give you way more space. I realize now this is way too small. Sorry about that. Okay, and so for this pattern, when you go over here, you can just write multiply fractions because you've already shown me that pattern, right? So you can just write multiply fractions. That's okay. Because you've shown me that pattern on a previous question. I don't need you to keep rewriting all that stuff, okay? And then come over here, 3 times 3 is 9. And then 24. And again, that pattern is just multiplying fractions, and we've already talked about that. And now again, here we go. You are now subtracting fractions with common denominators. So this one right here was gonna say multiply fractions. This one right here, you could say subtract fractions with common denominators. And this is that same pattern repeating itself. And that's why I really wanna show you how this kind of never changes. So 16 minus 9 is 7, and that's over 24. And this cannot be simplified. And again, you can write that from the previous thing you talked about. No common factors cannot be simplified. Okay, so you're going to start repeating and using previous information. That's the pattern I want you to see. All right, ooh, a big one. Okay, so I'm going to really try and make this one super clear. So the idea is, same idea up here, use prime factors to find a common denominator. See how the pattern repeats itself. So what I'm going to do is I'm going to write my denominators. I have a 9, I have a 2, and I have a 4. And I'm going to list these out first and then go find the prime factors. Okay, so the prime factors of 9 are 3 and 3. The prime factor of 2, well, 2 is a prime factor. And the prime factor of 4 is 2 and 2. And in this case, you can't just multiply the denominators. That really won't work here. What we do is we make a list as they occur, and I'll try to make that really clear, and that'll find us our common denominator. So first things first, I'll use a 3. That 3 is done. Okay. Do I have any other 3s? Nope. I'm going to multiply that by 3. That 3 is done. Do I have any other 3s? Nope. I'm going to multiply by this 2. That 2 is done. And because I have another 2, so this one's automatically done. So this one's finished, finished, finished. These ones go together. Oh, and I have 1 left times 2. And this will be my common denominator. 3 times 3 is 9. 9 times 2 is 18, and 18 times 2 is 36. This is what we can call our lowest common multiple, right? So our common denominator is our lowest common multiple. These are the patterns and ideas we're going to build on. So now coming over here, and again, on your test, I will give you so much space so you don't have to squeeze it in like I am. That's my fault. First things first, I have 3 over 9 times, now the question is, what do I multiply 9 by to get to my lowest common multiple of 36? Well, that is 9 times 4. Okay, and again, I'm multiplying by 1 to get to my lowest common multiple. What I'm going to add to that, I have 1/2 right here, times, okay, what do I multiply 2 by to get to 36? Well, that's 18. Okay, and coming here, what do I multiply 3/4 by to get to 36? What could it be? That's right, 9. Okay, and so now, what we're doing here is essentially you're multiplying by 1, right here, right? Multiplying by 1 to get common denominators. But every 1 is the same but different, okay? Because 4 divided by 4 is 1, 18 divided by 18 is 1, and 9 divided by 9 is 1. But they are different. And what this will give you is, now you can write about, you could say multiplying fractions pattern. Numerator times numerator, denominator times denominator. 3 times 4 is 12, and 9 times 4 is 36. 1 times 18 is 18, and 2 times 18 is 36. 3 times 9 is 27, and 4 times 9 is 36. And so now you talk about adding fractions with common denominators. That could be what you could write. You could write adding fractions with common denominators pattern. And you don't have to list out the whole thing because, again, you did it back earlier. Denominator stays the same. Okay, so 12 plus 18 is 30, and 30 plus 27 is 57. Now you can talk about how you simplify. You can write, actually this one you can just write simplify because we're not doing mixed numbers too much. But anyway, so you get 1. So you get here, and what's happening here, why I wrote the 1 is, so imagine you have 57. So 36 of those would make a 1. And so what's left if I take away 36? So you go 57 minus those 36. I got 21 36s left. And if you go here, there you go. And actually, you can actually simplify that fraction. And you can go into your simplifying fractions because they have a common factor pattern. But essentially, you're dividing by 1, but it's going to be 3 over 3. 21 divided by 3 is 7. And 36 divided by 3 is 12. Okay? And if you want to verify that, you could do it like this. So we had 21 over 36. 21 divided by 36 is 0.58333333333333. Okay? 7 divided by 12 is 0.5833333333. So you can see in the decimal form they're the same. But yeah, there you go. And again, I will give you so much space so you can reference all of your previous patterns. Okay. At this point, when I say make your own example, yeah. So take what you did here, just make your own example, and then use your previous patterns and show me or verify that your patterns still work. It's important that you show your work, but remember at this point, you don't need to write it all out. Here, I'll do a quick example for you. I can say like, I don't know, I always use the same ones, that's okay. 1/2 plus 2/3 plus 3/4 plus 4/5 plus 5/6. Oh boy, this is gonna get really big really fast. Maybe that was too big. But listing out my prime factors, the prime factors. So I have I'll just do it right here. We have 2, 3, 4, 5, and 6. Those are my denominators. So focusing on prime factors, I have a 2 that's already prime. I have a 3 that's already prime. This is a 2 and a 2. There we go. 5 is prime, and this is 2 and 3. Okay? So now I've listed out all my prime factors, and I can use these prime factors to find my lowest common multiple, which will be my common denominator. These are the math words we use. So I have a 2. I write 2. Any other 2s? Nope. Yep. Nope. Yep. So those 2s are done. Times 3. I have a 3. So 3. Boom. Any other 3s? Yep. Okay. So these, we don't use those anymore. Okay. Done, done, done. Oop. I have a 2. Any other 2s? Nope. And I have a 5. 2 times 3 is 6. 6 times 2 is 12. 12 times 5 is 60. So I know my lowest common multiple is 60. Coming back to my problem, and I guess I'll maybe write it down here. You just start multiplying by 1s that get you up to your lowest common multiple of 60. So I have 1/2. What is 1/2? 1/2 times what would give me 60? Well, that would be 30. Because 2 times 30 is 60, plus 2 over 3. Okay, how does 3 become 60? Well, that's 20, because 20 times 3 is 60. And again, you don't have to do an example this big. Maybe I'm just showing off. I don't know. Okay, and so we have 3/4 times. Okay, how does 4 become 60? That's 15. 4 times 15 is 60. Plus, what do we got? 4/5 times, that's 12. 12 times 5 is 60. Plus, I regret my choices. It's 10 over 10 because 10 times 6 is 60. Okay, showing my patterns, showing my work. Here we go. 1 times 30 is 30. 2 times 30 is 60. And that's good news because we want the same denominator, common denominator. Here we go. 2 times 20 is 40. 3 times 20 is 60. Okay. 3 times 15 is 40. 3 times 15 is 45. And 4 times 15 is 60. 4 times 12 is 48. 12, 20, yeah, 48. And then 5 times 12 is 60. And then 5 times 10 is 50. And then 6 times 10 is 60. And so you can see, now we have all the same common denominator. Once again, do you need to make an example this big and long? No. Can you? Sure, go for it. Okay, I'm gonna use my calculator to add these up quickly so we can get going. Let's see, can we all see that? Okay, so here we go. We have 30 plus 40 plus 45 plus 48 plus 50. 213, 60s, 213 60s, okay? That's how we do it, and we're using the fractions with common denominators. We're adding fractions with common denominators, okay? Now we can, you can think about this. One of these 60s, 2 would be 120, 3 would be 180. So I know there's 3 wholes that go here, 3 wholes. And then I had 180, so essentially you would say, well, what is 213 minus 180? And so then you'd be left with 33 60s. And that has no common factors, so they cannot be simplified. Wow! That was a heck of an example I made. Again, you don't have to make one that big and complex, but if you got the time and you're feeling good, I encourage you to go for it. All right. I forgot the explosion. Here's your explosion. I'm running out of steam, but we got this. Whew. When we look at this final one, again, at this point, we are just combining patterns. And you can, at this point, when you write this stuff down, you can just write multiplying fractions pattern, adding fractions with common denominators pattern. That's okay. So this one you can be kind of clever and kind of think about how do you want to solve this. So the first thing we know is that we got to multiply first. That's a previous lesson we talked about, order of operations, right? And we're going to do this order of operations. And before we multiply this, we do know that we can simplify first. And you can actually write that. You can just write simplify first. You don't need to write about that pattern. It's just something we talked about in class. But if you did simplify first, you would get 6 over 7 plus, so the 4 and the 16 can simplify. So let me just write this all out. So 4 divided by 4 is 1, 16 divided by 4 is 4. And actually the 3 and the 9 can simplify, so that'd be 1 over 3, okay? And now you just multiply. This is your multiplying fractions pattern. So you get 6 over 7 plus 1 times 1 is 1, 3 times 4 is 12. Now these do not have the same denominator, so now you need to use your patterns that we talked about earlier for finding common denominators, right? In this case, you could just say, use denominators to find a common multiple. And basically what's happening here is because there's only 2, if you just said 7 times 12, you would get 84, right? And so what you're doing here is you're just multiplying by ones, or kind of like sharing ones. So essentially you would say 6 over 7 times, and we're gonna use this guy right here, and that's 1 multiplying by 1, plus here 1/12 times 7 over 7. And remember, we took that 7 from over here, okay? So if you did this, 6 times 12, remember this is your multiplying fractions rule, or your multiplying fractions pattern. 6 times 12 is 72, and 7 times 12 is 84, plus 1 times 7 is 7, and 12 times 7 is 84. And just like that, now you have common denominators. Now this is your adding fractions with common denominators pattern, and you would get 79, because 72 plus 7 is 79, divided by 84. And let's see here, 9. And I do not believe these have a common factor. So you are done. If I'm wrong, let me know in the comments below and tell me what you simplified it to. But this video is getting long, so I'm trying to keep it moving, okay? Last one. Again, now we're just combining all of our patterns in an interesting problem. This one, again, order of operations will tell us that we should divide this first. And so what we're gonna do here is, remember, we're gonna multiply by the reciprocal. You can write multiply by the reciprocal. At this point, you could probably write keep, change, flip. That would put us here. Again, you can simplify first. You could just write that as your pattern, simplify first. And what that's gonna give you, let me just show you. Right, so this 4 and this 8 can work together to simplify, divide by 4, so that would be a 1 and that would be a 2. And actually this one can divide by 3, so 9 divided by 3 is 3, and 21 divided by 3 is 7. Makes your life a lot easier if you simplify first, okay? Now at this point, now you are just using your multiplying fractions rule, numerator times numerator, denominator times denominator. There you go. Now, if you looked at this and you say, ooh, now I'm subtracting fractions, but I need a common denominator, but you can actually look right here and realize that this 3 can grow to be a 6, and you can kind of save yourself a step and just say, well, I just need to multiply by 3 times 2 is 6. So I'm gonna multiply the denominator by 2, and I'll do the numerator by 2 also, because that way I'm multiplying by 1, and you can write about how you're multiplying by 1 to find a common denominator, and you're gonna get 7 over 6 minus 2 times 2 is 4, 3 times 2 is 6. Now you're just subtracting fractions with common denominators. 7 minus 4 is 3, 6 stays there, and voila! You can say now I will simplify by finding a common factor, and now you have 3 over 6 divided by 3 over 3, which is like saying 1. 3 divided by 3 is 1. 6 divided by 3 is 2. Voila. You're done by simplifying by using all those patterns, and bam! We did it. As always, be safe, make good choices, be kind to yourself, and be kind to each other. Bye!